How's it going, everyone? Another question that I've gotten actually several times that I didn't address in my previous video talks about the life expectancy of a battery and what I can do to extend or reduce that life. Now, there's obviously a lot of ways you can reduce the life. Short-circuiting a battery will obviously take it out very quickly. Drawing too much amperage too quickly, discharging the battery way down, basically. And there's several other things, but I'm going to talk about something that I really watch very carefully. There's actually a couple things that I watch real carefully. Number one is my total amp draw. So this particular battery, and I actually have another battery on the way, it should be here tomorrow, so I'll have these two hooked up in parallel to make a 12 volt battery bank. But anyway, this particular battery here is a 125 amp hour 12 volt battery, and it has a recommended discharge rate of no more than 15 amps per hour. That's DC amps per hour, or if you want to convert it up to 120 volts, you're looking at about 1.5 volts AC draw, or approximately 300 watts per hour. Again, these numbers obviously vary slightly, but that's a good estimate. So 15 amps per hour is the maximum recommended drain for this particular battery. This is a VMAX Tanks SLR 125, 125 amp hour battery. Now, it can be discharged at a rate of 30 amps for 1 hour only, and then that's it. So if I had a 30 amp DC draw on this, I could do that for 1 hour safely. It also has a recharge rate of exactly the same. So you recharge the battery at 15 amps maximum per hour, or you can do a quick charge or a fast charge, or sometimes called a hot charge, of 30 amps for 1 hour. And that's it. That's all you can do with it. Okay? So I watch this really, really carefully. So right now with just this one battery here, I've got a maximum draw of about 300 watts on the AC side, or 600 watts for approximately 1 hour. Unfortunately, because I only bring the battery down to 80%, which I'll talk about in a second, I'm only able to get about 20 amps DC total, 20 to 25 amps approximately, before the battery's at 80%, and then I have to cut off, basically. So that limits my ability, because I can take a 15 amp draw for about an hour and a half, and then I have to recharge the battery. Or I can do a 30 amp draw for about 45 minutes, probably 50 minutes before I have to cut off. Okay, that'll keep the battery at 80%. Now, why do I keep the battery at 80%? Well, with a deep cycle battery, the further you bring it down, the less life it's going to have. That doesn't mean that if you bring the battery all the way down to zero, suddenly the battery's going to be dead and it'll never recover. But with most solar setups that use batteries for storage, or renewable energy, wind, whatever, they use battery for storage, you'll notice that their battery banks are very large. Now, that's not just so that they can store lots of power and be able to use lots of power. It's to spread the load over the batteries, as well as have more in reserve to as close to 50% or sometimes higher of capacity to make the batteries last longer. This particular VMAX Tanks battery, this SLR 125, if I take it to 80% of charge, which is about 12.8 volts approximately, then I should get between 3,000 and 5,000 charges successfully out of this battery. If I bring it down to 50%, I'll get probably about 1,000 to 1,500 charges for the battery before it's toast, before you have to replace it. Now, I shouldn't say toast, but basically its ability to hold a charge and be able to put out the voltage is going to be hindered, basically to the point where it's not worth keeping the battery. Okay. So what I do is just basically I bring the battery to 80% and no more. And again, this is a limiting factor because my battery bank is obviously small. I've got one single battery. And so my limitations are that I can only bring it down so much. Now, I have way more energy output than I do have battery storage, and it's unfortunate, but I'm working on that. Batteries are the next step, obviously. So once the sun goes down and I start dipping into the battery, I can only go so far. So I'd start unplugging things. And when the sun is completely down, I basically shut it off. And I try to stay around the 13 volt range, the 12.9 to 13. As the sun is going down, what I do is I cut power to the inverter, and I let the last 4 or 5 amps of solar recharge the battery. That way in the morning, when I start turning everything back on, I've got some reserve energy there. Then when the sun comes up, I'm actually able to bring the battery back up without a problem. I really watch the weather, if it's going to be cloudy, things like that, because I need to know the next day what my outlook is for actually recharging the battery and sustaining the system. I would prefer to keep the battery at full charge or 90% charge all the time, but that's just not possible. And some would actually say that it's not worth the money, that if you buy a deep cycle battery, the optimum value is to actually bring it to 50% and then recharge it. You'll get your 1,000 or so cycles, then you throw the battery away and you buy a new one. Okay, that's fine, but I'm doing it this way, more cautiously. And I want to make sure that the batteries have the most life as possible. I mean, I have the potential here to get 10 years out of these batteries. And at $260 a battery, that's what I want to do. And I do not have my entire house running off of this battery, okay? So I know my limitations. As I add more batteries, I will be able to extend what I can actually power, okay? So I have room to work with here. But there's a lot of things that I won't be able to power with this come towards winter time, like a 1500 watt ceramic heater. A 1500 watt ceramic heater means that I would require about 5 batteries safely. At least I would be able to draw from 5 batteries down to 80% without them overheating, okay? So there's limitations to what I can actually use, and I've gotten a lot of questions about, oh, can you run your fridge? Oh, can you run your window air conditioner? Oh, can you run your toaster? Oh, there's a lot of things. Unfortunately, in this current setup, I cannot do that, but I'm working on it. Now, another thing that I do, and this is another question I got, because I had mentioned I've got my computer running and a couple box fans. Well, if you total all the energy that I'm actually using at peak, it's close to 550 watts. If I didn't have any solar going into it at all, if I had no outside source of energy coming in, it was just the battery, that load is about 550 watts. So I was asked, well, okay, so you're bringing the battery up to almost 600 watts draw. That's not good for it. Well, here's the deal, all right? So right at this particular moment, I'm generating 20 amps. Let's just say 20 amps on the nose. So I've got 20 amps of electricity coming in, flowing through the system. It's coming in, and it's going straight to this inverter, okay? The battery itself is like a big resistor, okay? The battery doesn't want to take a charge, all right? That's just the way that it is. It's by nature doesn't want to take a charge. It wants to discharge. So as the solar panels, there's the energy from the solar panels is coming in. It's coming in through the line. It's coming down to the battery itself. It's actually being picked up immediately by these clips here that go to the inverter, because electricity always follows the path of least resistance, and this inverter is sucking up all the energy that it possibly can as soon as it hits whatever. So as a complete circuit here, it's not as if the panels are sending their power to the battery and then the battery is sending the power out to the inverter, because this is all connected as one unit. It's all connected as one circuit. It's all one, okay? So as long as there's energy there from the panels to be able to power this, it will always draw from the panels first. Now, let's say I get a cloud. Okay, a cloud goes over and I go from 20 amps to, let's say, 10 amps, but I still have a 20 amp draw. Well, what's going to happen? The electricity that's coming in, that 10 amps, is going to go through the inverter, and the inverter is also going to pull 10 amps from the battery and bring that up to make 20 amps and then send it out through the plugs. That's how it works, because I had some questions about that and whether I'm overheating my battery because I've got such a huge draw. Well, that draw there is actually not completely the battery. When there's no sun, it's all battery. When there's sun, some of that solar energy is going to the inverter, and some of it is actually, I shouldn't say it like that, some of the energy is coming from the battery, some of the energy is coming from the solar panels to power the inverter. So if I have, let's say, a 20 amp draw, and the solar panels are putting out 25 amps. Well, 20 of those amps that is requested from this inverter is going to the inverter and out here. And then the other 5 amps is going down here to charge the battery. Okay? That's how that works. It's pretty simple. I've been asked that several times, because the thing is that if this battery would be completely toast right now, if the case is that it's charging at 600 watts and then I'm also drawing 600 watts, it would completely toast this battery in no time. So that's the thing is with renewable energy, you want to try to make the most use out of the daylight hours with solar. You want to use your dryer, your washer, your other appliances during the day when you're generating electricity to try to keep the batteries as basically out of the system as possible. Then when you're generating less electricity, you've got the capacitor here that will actually feed your draw, your needs for you without shutting everything down. Because if I had this connected directly to the solar panels, yeah, it would stay on while the voltage stayed up to, 12, 13 volts. But as soon as the cloud went over, this thing would shut down because it doesn't have enough juice to power whatever I'm pulling from. That's why you've got a battery here. The battery here is there to supplement the energy requirements of the inverter. And if you don't have enough solar, then you need to pull from your battery. If you have enough solar or wind or whatever, it'll pull from that first, and then when there's a dip, it'll come down to the battery. So that's how it works. That's why I'm not drawing off the battery. I could literally go all day long and not draw off the battery one bit. And if it was a perfect world, it'd be a 1-to-1. So my 500 plus watts of solar would then, turn into 500 watts of output right here. And then I wouldn't have to bother the battery at all. So it's obviously not a perfect world. So I try to keep my voltage above 12.8 at all times and 12.5 under load at all times. Once I hit that 12.5 mark, that's usually where I start pulling back until this thing comes back up. It's very tedious. Believe me, this is not something that I sit here and enjoy watching this thing, but that's why I need more batteries. So I don't have to worry about, oh my god, the battery's down to 12.5. I better pull some stuff. Or, oh crap, the battery's completely full. I better hurry up and start plugging things in. Once I increase my capacity, I won't have to worry about the draw as much. I won't have to worry about, are they float, are they not float? If they're at float, then this charge controller is going to be trickling back and forth constantly. I won't have to worry about that. So the key for me right now is to increase my capacity. And batteries are very, very important. Good batteries. I've seen the craziest things on YouTube. And you can look for this stuff where somebody will have one cheap, small, deep cycle battery. And they'll have an air conditioner, a stove, all sorts of things plugged in. And I can tell you right now, that battery is going fried. I mean, it really is. There's way too much draw on that battery. So I take really good care of my batteries. I make sure that my batteries are going to last. I don't overdraw them. I watch to see what energy I have coming in and try to use an equal amount of energy. And if there's a cloud, that's where the battery picks up. And I keep an eye on the weather. I really do a lot. I'm really involved in this system a lot to make sure that I'm getting the most possible out of it, and also longevity. That's really important. I monitor these voltages. You can see right here, and this is from VMAX themselves at 80% charge at approximately whatever the temperature is right now, which it's close to 70 actually in here. So we're talking 12.8 or 12.78 volts, probably in the 12.8 area. So that's a good rule of thumb for me. It's usually between 65 and 70 in our house. It actually could be more, which would bring the voltage down. But this is in a room that's out of direct sunlight, so these batteries aren't going to be exposed to 90-degree sunlight or anything else like that. But anyway, so yeah, I really do take good care of this system because I want it to last for me. I want it to be there in case of an emergency. I want to be prepared for things that if the electricity does go out for a couple of hours, a couple of days, a couple of weeks, I know exactly what my limitations are. I know what is most critical for me to survive without the electricity, and that's why I've got this setup, and I can expand. I can continuously expand on that. That's what's great about it. When I get the battery bank up to where I need it, I'm going to need a bigger inverter. When I get the bigger inverter, I'm going to need more solar panels. When I get more solar panels, I'm going to need more charging capabilities. I'm going to need more batteries. I mean, it compounds. And my goal is to be able to completely supplement my energy so I'm completely off the grid. And that takes a lot of work, but it's well worth it. Believe me, when you're the only one on the street that's got electricity, it's pretty cool. And everyone else is losing their fridge, everything. It's happened. And, if you spend a lot of money on a generator, you spend a lot of money on gas to run it, generators get stolen. I mean, I would much rather go green anyways. That's my main motivation, is to be green. And, this is really helping a lot. So it's a great project. I love it. I love watching these numbers move around. I love watching those numbers move around. If you're kind of a nerd like me, then you'll enjoy these kind of things. Putting this together, making it as safe as possible. Watching the solar panels do the work for you. Watching them power, something as simple as a box fan. I mean, it's just so cool. And I've been watching my electricity usage from the grid, go down, 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 down. I was sitting at about 11 kilowatts a day, and now I'm averaging about 9.9 kilowatts per day. So it is going down. It's going to take some time. It also takes us actually cutting back on all sorts of things, which my wife isn't too happy about, not taking as long as showers, but that's just the way it is. You have to learn to survive on what's minimally necessary. And so anyway, enough about that. I kind of dragged on about other stuff. So, all right, so I'll get another video when I hook the other battery up. And yeah, so all right, if you have any more questions, please let me know. Take care, guys.